Hey everybody, in this recording we are going to do a semi-formal lesson on synthetic division. We most recently had a lesson on long division. We did some practice. I think we're getting pretty good at it at this point, so I think it's time that we take a look at synthetic division. Now, we'll talk about this more in class, but synthetic division can really come in handy when dividing polynomials because long division can be a little bit cumbersome, tedious, a lot of room for error, especially with that subtraction around that whole quantity, and everybody's always breaking all the rules and making silly mistakes there. Synthetic division kind of removes part of that obstacle because we will be setting the factor equal to 0 and solving for x, which sort of inverts the sign for us already. And instead of subtracting, we can just add. So we avoid a little of that distribute the negative nonsense. But there is a catch, and the catch is that while it's more convenient, it's nice and clean, it moves quickly, you can't use it all the time. We can only use synthetic division when we are dividing by a linear factor, and that linear factor needs to have a lead coefficient of 1. So let's write that down. Down here we have these little notes. I do suggest you read through this cover sheet, and we'll probably read through it in class anyway, but let's just write this down. Just to get started, only allowed when dividing by a linear, we should know what linear means, by a linear factor. Now I'm calling it a linear factor. Even though I'm using the word factor, it doesn't mean that it is necessarily a factor of the dividend, the thing that we are dividing into. It is a factor of that thing in the situation that you have no remainder or the remainder is 0. But I'm using the word factor as describing what we are dividing by. It is a polynomial factor, just not necessarily a factor of the thing we're dividing into, the other polynomial, the dividend. It's like someone could be someone's mom. They're not necessarily your mom, right? So sort of like that. Only allowed when dividing by a linear factor whose lead coefficient equals 1. So you might see it written as, say, ax minus b such that, there's symbols for such that, but right now let's just use the words, such that a is equal to 1. Oh, I'm not even on the screen. My bad. There we go. So only allowed when dividing, let's really make this a big division symbol. I don't want it to look like that little hyphen I had put there to be multiply or subtract or something. Dividing by a linear factor whose lead coefficient is 1, ax minus b, such that a is equal to 1. What do some examples look like? X minus 2, x plus 500, x minus 302. Those are all examples of something that we can use as our divisor, and something we cannot use as our divisor, well, that would be 2x plus 5, x squared minus 8, x squared plus 4x plus 10. Those are not allowed. All right. In this case, it's a linear factor, but my lead coefficient is not 1. Here, my lead coefficient is 1, but it's not a linear factor. And this is wrong in 2 ways. The lead coefficient is not 1, and it's also not linear. So those would be things that you cannot use synthetic division on. These are things that we can use synthetic division on. And these are examples for our divisors. right? The thing we are dividing by. And let's get into it. We'll do an example, and I think it's really the best way for us to wrap our minds around it. So I am, as was described in the cover page there, I am going to be revisiting examples we did in the long division packet. The reason I'm doing this is so that we can sort of compare and contrast, see what they have in common, what makes them different, what makes them similar, and so on. So here is my first example. We're going to divide x to the third plus 2x squared minus 5x minus 6 by x minus 1. It is linear. We're talking about the divisor. Check. And the lead coefficient is equal to 1. Check. So we're good to go. So how is it that we get this started for synthetic division? Now I kind of gave a bit of a clue earlier. One thing that we're going to do is we're going to take the divisor, in this case x minus 2, and I am going to, let's do this over here, take the x minus 2 and set that equal to 0, just like zero product property, just like we did in lesson 12 when we were solving polynomial equations, just like we did in lessons 13 when we were graphing polynomials and looking for x-intercepts. So anytime we solve a polynomial by factoring, we set each factor equal to 0 and we apply what we call the zero product property. So that's essentially what we're doing right here, okay? Add 2, whenever you need to get numbers to the other side of your equal sign, I hope we all know, you do the inverse operation. So those cancel, meaning they turn into 0. X equals 2. The number 2 that we just got, that 2 is really going to act as the synthetic divisor. So instead of using x minus 2, which has a minus sign in it, we're just going to use 2. A little cleaner, a little less mess going on. We have no variable. We also flip the sign so that subtraction we did in the long division could now become addition and serve the same, allows for the same procedure to happen. So 2 is going to be my divisor instead of x minus 2. All right. So I'm going to write a little 2, and it's going to go into a little box, kind of like a little right angle box. Different teachers may set this up, a little differently, but it's going to look something like this. Now, part of what makes this synthetic is we're not going to have x written anywhere. No x, no exponents, but the placement of the number really has an undertone of x to a power. Let me show you. You start with your leading coefficient. In this case, it's a 1. I'm going to write that down a little over from that little box. Now, similar to long division, we're going to need placeholders from time to time. 3, 2, 1, none. Well, I don't need any right now. 1, the next coefficient, is 2. Leave a little room. -5. Obviously, I don't need to write the plus for positives. And -6. Now, even with the problem totally covered up, someone could still figure out what the division was. How so? The last number will always be our constant. So that's just -6 at the end. Then moving up, that's going to be your linear term, minus 5x, plus that would be 2x squared, next degree up, and that will be a 1x to the third. So you could figure it out, and if x equals 2, subtract 2 to get it back equal to 0, we'll have that x minus 2. So really we could work backwards from the work and figure out the question. Now I leave some room. Okay, I'm just going to circle this little bit of information just so it doesn't blend in with the rest of my problem. I'm going to leave a little bit of room for some work. So it's like almost like 3 lines if you have lined paper. This is 1 line. You're going to have a second line I'm going to leave blank right now, and then a third line underneath this line. That went a little too far, sorry. So we're going to bring down the first number. It isn't always a 1. If it's a 5, you bring down a 5. And by the first number, I mean after the divisor, so that leading coefficient. Putting down this one. Then we take the number, the new coefficient times our divisor, add them down, add them, the two numbers, and feel a little wiser. New coefficient times the divisor, add straight down, feel a little wiser. New coefficient times the divisor, add them down, and feel a little wiser. Now, guess what the last number represents? You guessed it, the remainder. So I kind of like to box that off so I don't forget. In this case, it's a 0, as it should be. Now, remember, we divided an x to the third polynomial expression by an x to the first. My answer should be x to what power? So all we need to do is really start 1 degree less with the first coefficient. We're going to trickle down. The one before the last should be my constant term if I do it correctly. Then that should be my remainder. So what will the answer be, you ask? Well, it will be 1x to the second, positive, so plus 4x to the first, plus 3 with nothing, plus my remainder 0 over x minus 2, which obviously I hope we all know. We don't need to write this. Really, your answer could just be written as x squared plus 4x plus 3, and that's your quotient right there, right? Done, beautiful. The remainder was 0. This is a factor of that cubic polynomial of 4 terms, and so is x minus 2. Let's look at the next example. We're going to take our divisor, right? If you want to press pause, try this by yourself, by all means, go nuts. If you're ready to go over it with me, or if you just want to do it with me instead, here we go. Take the x plus 3, set that equal to 0. That gets us that x equals negative 3. That is going to be my synthetic divisor. This is the same dividend, so I won't need a placeholder. I know that already. 1, 2, negative 5, and negative 6, leaving a line of room. Bring down my first coefficient. New coefficient times the divisor. Add them down. Synthetic makes you feel wiser. I have no idea. We have to fix this rhyme, make it sound good. Negative 1 times negative 3. New coefficient times the divisor. Add them down. So negative 5 plus 3. Feel a little wiser. Negative 2 times negative 3 is 6. There we go. Another remainder of 0. So what's the answer? We start 1 degree less. So we had x to the third. So this is going to be x to the second minus x minus 2. What if I wanted to show the product, right? I could also write x squared minus x minus 2 times something equals x cubed plus, cubed. X cubed plus 2x squared minus 5x minus 6. So what do I need to put right over there, you may ask? Not negative 3, not x minus 3. Why am I stressing this? Because everyone's going to mess this up. Okay, so if you're listening, don't mess this up. Like literally everyone does this part wrong. They write the wrong thing or they don't write it at all. Come on, don't do that. Don't be that. Don't be that guy or girl. So you could also describe that. What if it asks you to factor all the way? Well, we have one part done. That's a linear prime factor, and I can use AC method, grouping, whatever, on this and finish by hand if I needed to. How about here? Divide x cubed plus 2x squared minus 5x minus 6 by x squared plus 4x plus 3. Want to give it a try? Press pause, try, and then unpause when you're ready to go over it with me. Hopefully, we're all very clever, and we saw right away that this is not allowed. We can't use synthetic division on this. We would have to use long division. This is not a linear factor. This is a quadratic, and that is certainly not allowed. All right. Our lead coefficient's 1, but it's not linear. This next one looks pretty good to me. We can use synthetic here. So if you wanted to try this one on your own, go ahead and do that. And then unpause when you're ready to do it with me. No tricks this time. If you're ready, we take the x plus 1, set that equal to 0, like 0 product property, and we get 0. We subtract 1, we get x equals negative 1. There's my divisor. I'm going to get these coefficients going across. 1, 2, negative 5, negative 6, leaving some room. Bring down my first coefficient. New coefficient times the divisor. Add them down. We've never been wiser. New coefficient times the divisor. Add them straight down. We've never been wiser. Negative 6 times negative 1 is 6. Here we go again. Remainder 0. Now, why did these all give me a remainder of 0? If you look back at that first page, the x plus 1 times x plus 3 times x minus 2, this is how we made this problem. Those are the 3 factors, the 3 prime factors that go with this example. Just to finish up how we write our answer, you don't leave it like this. This is not giving you credit, okay? X squared plus x minus 6. You know what else is not getting you any credit? If you put the wrong number in the box. If you put plus 1, no good. No good, guys. All right, here, number 5 is just worded a little bit differently. Divide x plus 2 into x cubed plus 2x squared minus 5x minus 6. Same exact type of question. It's just set up differently. I tried to spice it up a little along the way. This is still, we're dividing into, so this is what we're dividing by. X plus 2, we set that equal to 0. X equals negative 2. I'm just going to rewrite it because I don't have that much room because of how I did it. So now 1, 2, negative 5, and negative 6, leaving some space. Bring down the first coefficient. New coefficient times the divisor. Add them straight down. We've never been wiser. New coefficient times the divisor. Don't mess up multiplying by 0, guys. Add them straight down. We've never been wiser. New coefficient times the divisor. Add them straight down. We've never been wiser. So what is it that we have here? Well, our answer this time has a remainder. It's going to be x squared. Now, if I really fully wrote this, I would even do a 1x squared, a 0x minus 5. Then, the way we handled the remainder, plus remainder over, and this is also on the other side of on the first page, typed up for you guys, over, not negative 2, go all the way here, x plus 2. Or more normal people would probably write this as x squared minus 5 plus 4 over x plus 2. That's a little bit more natural looking, right? So there's your quotient. We do have a remainder. X plus 2 is not a factor of the original polynomial. All right, here we go. Got another one set up a little differently down here. So what number goes in the box? If you thought it was -5, go you. This one's only quadratic. We don't have that many terms to stress about. Bring down the first coefficient times the divisor. Add straight down. We've never been wiser. New coefficient times the divisor. I know it's going to be tempting, and it probably was in the long division too, to get like a 1 or a -1 with the 16 and 15, because like who wants a big remainder? But add them straight down. Sorry. It's a little annoying. Don't autocorrect. Don't force something to fix. Now we are dividing a quadratic by a linear. So this is going to be a linear solution. This is your remainder, constant, linear, and you just count up from there, right? So the answer is 4x plus 3. Now, could I write plus and then put -31 over? Yes, but I could also be a normal person and write minus 31 over x plus 5. Not x minus 5, x plus 5. So again, x plus 5 is not a factor of that quadratic. Hopefully this is going okay. We have 6 more examples for you. I think that you can finish those on your own, and we will have those solutions in a continued portion of this video. So I hope this made sense. Actually, as one part of an extended, I want you, as an extra question to do right now. I know, sorry. I want you to add this and, well, I guess it's subtract in this case, and this by finding a common denominator. I want you to add, okay? And then I want you to tell me what you found as your answer and what you learned, all right? So we will continue this discussion. Just remind me in class, all right? See you guys, or you'll see me in class or in the next video. Have a great day. If you think you understood and you like synthetic, thumbs up. If you're like, this is so confusing, I can't remember when to add or subtract, what are these numbers? Give me a thumbs down. I don't care. Feedback is important. Have a nice night. Bye.